All right, folks, it's Bass Action, back in action here. This is our last video for this semester, so you can do a little golf applause on your end. We're going to do a couple things on this video in terms of pausing it and having you guys practice some stuff and then coming back and checking your work. So on this page of notes, we are going to solve systems of equations that are non-linear, and not just thinking about our planes that we did in the last units, but this is going to be a combination of all of the shapes that we've studied this semester. So there's a lot of review on here. Our square root functions, our circles, our lines, our rational functions. So it's going to cover a lot. So what we're going to do, and what I want you to do first, is the review portion, and that's going to be graphing each of the systems that we have here. So on this top one, of course, everybody would know how to graph that line. That one's going to be pretty easy, but I want to give you a little bit of a hint for the other equation here. We actually did this one way back in August. So the hint that I'm going to tell you is thinking about getting this into a form that we're familiar with. So if we square both sides of this equation, so we'd get a y squared equals a 4 minus x squared, because I'm trying to get rid of that square root. And then I move my x squared to the other side. I'll have my x squared plus y squared equals 4. What I can see that I really have going on here is the equation of a circle with a radius of 4. Now, what I need to remember is this started out as a square root function, so we only want the positive half, okay? So we want the top half. So we're only going to want the top of this circle. We aren't going to want the entire circle itself. On the next problem, just moving this on down, on our next problem, we're going to graph a circle. Its center is 0, 0. We will need to approximate this radius. So we could type this in our calculator. Remember, it's the square root of 10 is our radius. So we can approximate that is about 3.2. And then our other equation is just another line, no big deal. Moving on down to our last example, we have a simple rational function that you would have done in your Algebra 2 classes. So the top one should be pretty straightforward, but this bottom one might require some thought, a little bit of review. We're going to need to complete the square. We need to get this in a good standard form so that we can graph this. So completing the square on this, we'll go ahead and we'll do that piece. We'll have our, oops, sorry about that. Every once in a while I forget. Okay, so we'll have our x squared plus our 4x plus our blank and plus our y squared. And then I'm going to move that 4 to the other side. So I'll have a 4 plus a blank on the other side. So completing my square, I'm going to take my 4 divided by 2 and square it, and that gets me a 4, and I'm going to put that on the other side. So we can jump to the x plus 2 quantity squared plus our y squared equals our 8. So when we go to graph this, we can see that this circle has a shifted center to a -2, 0, and our radius, we are again going to have to approximate that square root of 8. So our radius will be about 2.8. Okay, so I'm going to slide this back up to the top. I want you to pause the video and I want you to graph all 6 of these equations and then come back and check your graphs. Then we will look at how to do it algebraically. That's our new part. So pause the video, check and graph everything, and then come back and check them. Okay, so now let's take a look at our graphs. And what we really need to keep in mind on our graphs here is that graphs are not super precise. It's great if we have a computer program to graph it for us, like our Desmos.com. But if we are graphing these by hand, unless we're plotting lots of points, we might not be able to tell. So for example, I have the top half of my circle and I have my line, okay? Now, it looks like it might intersect here, it might not. It depends how precise I was in my graphing. On my next one, where I have my circle and a line, I can definitely feel confident that that's going to intersect twice. I don't know exactly the values, but I can tell it's intersecting. On my next one, I have my circle and I have my rational function, okay? And I've even plotted some actual points here, but again, these were still kind of sketches. And what I'm going to tell you is that when I look at my graph based on just the sketch of my rational function, it doesn't look like my circle and my rational function intersect at all. But what I'm going to tell you is a little bit of spoiler when we get to the bottom here. It does intersect. In fact, there are going to be 4 places where this circle and this rational function intersect. They are going to intersect very nicely at 4 spots. So we're going to see that algebraically here in a little bit. So we don't want to depend too much on our graphs because we understand that they're not going to be precise, but our algebraic answers should make sense when we're done. All right, so let's take a look at how to actually solve these algebraically. So with our systems of 3 variables, what we found is that we were doing elimination pretty consistently. When we are working these systems of nonlinear equations that are all sorts of random shapes, what we're going to find is that substitution is going to be our most common approach. So on this first one, I noticed that both of my equations equal y, so I can set those equal to each other. This is a great review of all of our algebra skills. So I'm going to have this 2x plus 4, and I'm going to have the square root of 4 minus x squared. From here, I'm going to square both sides of my equation. That left-hand side, I need to be really careful and FOIL this entire thing out. So I'm going to get a 4x squared plus a 16x plus a 16, and on the right-hand side, the radical just drops out, 4 minus x squared. I move everything over to one side, so I'm going to have a 5x squared plus a 16x plus a 12 equals 0. And then I'm going to factor this. And if you want, you can pause this and try to factor this. I know I'm going to have a 5x and I'm going to have an x. In order to get my 12, I can do this with guess and check, or I can use it, do this with a longer method if I want. Or we can use our longer method. Sorry, I had to pause the video there. So we could use a longer method, or we can do it by guess and check. I'm just going to go ahead and fill this in, and I'll let you use whatever strategy you want. But this is going to factor into a 5x plus a 6 and an x plus a 2. If you're not 100% certain on that, we can check that. Of course, our 6 times 2 will give us our 12. Our 5 times 2 is going to give us our 10, plus our 6 gives us our 16. All right, so what that does then is that gives us an x value of a negative 6/5 and an x value of a negative 2. So what we're going to do is we're going to actually substitute those values in and ensure that we actually get points that are on our graph. Now it's going to create 2 ordered pairs specifically, and what you can do is over here to the side, you can kind of set these up as ordered pairs so that we can complete them later. It helps us kind of keep track of what we're actually doing. So we're going to substitute that negative 6/5 into one of our equations. Obviously, the line is going to be the easiest. So I'm going to say y equals my 2 over my 1 times my negative 6/5 plus my 4. I'm going to put that over 1, multiply my top and my bottom by 5. And I'm going to get a negative 12 plus a 20. So I'm going to get 8/5. Okay. So I can put that value down here as my 8/5. So what I can see is that this point has a negative x coordinate and a positive y coordinate, so it makes sense. If this had turned out to be negative and I had a negative x and a negative y, I would recognize that as an extraneous solution. So now I can take a look at my negative 2. So I'm going to say y equals my 2 times my negative 2 plus my 4. So that's just going to give me a 0. so I can fill that in, and that makes sense as well. If I come over here at a -2, my graph doesn't necessarily show it perfectly, but it seems reasonable that that would fit. So that is my algebraic solution, and it does sync up pretty nicely with my graph. All right, now the next one. This one, I'm also going to do a substitution, and I'm going to pause the video on this one and let you do some algebra so we can check along the way. So I'm going to take this y and I'm going to substitute it into that one. So I'm going to have an x squared, got to watch your parentheses, x plus 2 quantity squared equals 10. So if we're going to pause this, you can pause the video if you want. I'll have my x squared plus 4x plus 4 equals 10. 2x squared plus 4x minus a 6. Everything's divisible by 2. X squared plus 2x minus 3. This factors nicely. So now I have two values for x, and again, I can start these ordered pairs. I know I'm going to have an x value of a -3, and I'm going to have an x value of a +1. So now I can continue. Of course, the line's going to be the easiest. So I have y equals, I'm going to do the -3, so I'm going to have a -3 plus a 2. Gives me a -1. If I go look at my graph, that makes sense. -3, -1. My graph isn't perfect, but it's close enough to feel comfortable. Then I'm going to do my 1. So I'm going to have a 1 plus a 2. That gives me a 3. I can complete that ordered pair, check the graph. Over 1, up 3. That one looks really, really good. All right, our last one. This one is going to be pretty complicated. Actually, I'm going to put a box around this before I go on. This one's going to get really complicated, and we're definitely going to want to pause the video and check some of our algebra. All right. Again, we can do our substitution, but it's going to get complicated. So I have this y. I'm going to plug it in there, but I have to put a fraction into this and then square my fraction. So when I plug this in, it's going to look like x squared plus 4x plus, in parentheses, 4 over x plus 2 quantity squared minus 4 equals 0. Okay, so pause the video and I want you to square this fraction first. Okay, do we agree on that fraction squared? Now, the next thing that we can do is we can, if we want, we could set this up as a proportion and cross multiply, or what we could do is we can clear these fractions. Either way, we're going to end up with the same amount of algebra. So believe it or not, our common denominator is going to be that we need to multiply everything by is this x squared plus 4x plus 4. So I'm going to need to take this entire polynomial and I need to multiply it by this, x squared. I need to multiply this 4x times that. This 16 will be left with because those will cancel, and then I need to distribute a -4. So we're going to have to be really organized with that expansion. So I want you to go ahead to distribute that and collect all your like terms, and then let's see what we get. Okay, so the chances are strong that you might have made an error in this, so let me just go over this very quickly where I'm not having to write simultaneously. So what I did was I took this x squared and I distributed it to each piece in there, and that got me this line. Then I took my 4x and I also distributed that to each piece in there, and that got me this line up to right here. This 16 came from when I multiplied this times this, the denominators canceled. The last bit was distributed in the -4, and that gave me that. Now, what that does is that allows me to see, if I'm looking vertically, that these are going to cancel. These 4x squares, -4x squared and +4x squared, are going to cancel. So that leaves me I can kind of be thinking vertically. I have x to the fourth plus 8x cubed plus 16x squared equals 0. Now, thinking back to chapter 4, I can factor out an x squared, and I get x squared plus 8x plus 16 equals 0. And I get x squared, and then I get x plus 4, and x plus 4 equals 0. Now, from there, I can now set up my ordered pairs. I can see that 0 is one of my answers, and I can see that -4 is the other answer. These ones I can actually do mentally. If I take a 0 and I plug it back in here, I'm going to end up with 4 over 2, or in other words, 2. And when I look at the graph more precisely, that seems to make sense. I think earlier I mentioned that we would have 4 points of intersection. Spoiler, our one in our class that we're going to do in class is going to have that. My memory was just jumbling those. If I take my -4, I plug it in here. If I put my -4 in here, I'm going to have a -4 plus 2, or in other words, a -2. So I'm going to get 4 over a -2, or in other words, -2. And that also graphically totally makes sense right there. So even though my graph wasn't super precise, I've got it. So this might have seemed like a lot because it is really, really, really stretching your algebra skills. They will take practice, and you got to go slowly.